Hello and welcome to my channel Technical Intercepts. Today in this video I'll be covering second type of complement called Radix complement, also called as R's complement. So how you will find the Radix complement of a given number. If you have a number n whose base or radix value is r and it has an integer and fractional part. If the number of digits in the integer part is n and if the number of digits in the fractional part is m, then the formula for the radix complement is, as you can see here, r to the power n minus n, and this formula is only applicable if the number is not equal to 0. If the number becomes equals to 0, then the radix complement of that number becomes 0. Radix complement is actually the addition of diminished radix form complement, also called r minus 1 complement plus unity, that is 1. And let us try to find the radix complement of decimal number system. You know well that the radix or base value of decimal number system is 10. So the radix complement for the decimal number system is called as tens complement. Now the steps involved in calculating the radix complement of decimal number system are: you have to first leave the LSBs 0 till you get a non-zero digit. Once a non-zero digit from the LSB side has occurred, you have to subtract that non-zero digit from 10, and again from there you have to subtract the other non-zero digits approaching towards MSB from 9. Let us see with an example. Can you see the steps here? Yeah, that's what I said. And you know that tens complement of a decimal number system is equal to 9's complement plus 1. As I said, R's complement is the diminished radix form plus 1. From there I got this: 10's complement of a number is equal to 9's complement plus a unity. This is an example. Here in the problem it is saying to find out the tens complement of 6250. So you can use either the formula, or you can just follow the steps, or you can either try to find 9's complement and then just add 1 to it. So by using formula, calibrate all those values, that is n is equals to 4, because 6250, when you count numbers in that total number, you have n is equals to 4, 1 2 3 4, and the base or radix value of decimal number system is 10, and the number itself n is 6250. Use the formula, that is just substitute the values. You will get 10 power 4 minus 6250, 3750. This result should be matched with other type of methods. Now, as I said, you follow the steps, and by following the steps, just leave the 0 from LSB. So you occurred 0 here, leave it, and then try to approach towards MSB. You have got a first non-digit 0, that is 5. Subtract it from 10. So by subtracting it from 10, I am getting 5, and the rest of the values should be subtracted from 9. So after subtracting 62 from 99, I got 37. This value got matched with the value I obtained from the formula. And you can also find 10's complement by doing 9's complement. That is, just subtract all these four values 6250 from 4 9's. You will get 3749. Then add 1. Here you are doing 9's complement, and add 1, you will get 3750. So these three values got matched. Next, if you have a point in decimal number system, follow the same steps for the integer part and also for the fractional part. Here in the integer part you don't have any number, so n becomes 0 and r is equals to 10 and n is equals to the number itself. So substitute in the formula 10 part 0, that is r power n minus n. You will get 0.6733, or use the steps. In the fractional part, first non-zero digit has been occurred, so subtract it from 10. Here I am talking in the fractional part, and the rest of the values are subtracted from 9. So 3267 is subtracted from 3 9s and 1 10. You will get 6733 and the 0 0 as itself 0, because this is the part of integer, and in the steps you have to follow the first step, that is if a 0 occurs just in the LSB, just drop it as complement of binary number system. So the r's complement of binary number system is called as 2's complement, because r is equals to 2 for binary number system. Leave all significant zeros as it is. If the first one occur from LSB, after you have kept unchanged all those zeros at LSB, if the first one occur, then keep it unchanged. Now after that you have done with it, just toggle all the values, that is 0 to 1 and 1s to 0. Let's see with an example by using formula and by using steps, two methods. Or you can also do 2's complement of a binary number first by trying to find 1's complement, and after you get 1's complement of that number, then add 1 to that result. We will see even that too. So use a formula r power n minus n, substitute the values. R is 2, n is equals to 9, that is number of digits in the binary number, that is this one, and n is the number itself. N is equals to 9, this is the count and this is the number itself. If you count all the zeros and ones, you will get 9. So after substituting, you will get 2 power 9, and that 2 power 9 value is equal to 512, which is decimal in form. So convert the decimal number into binary, you will get 1 000 000 000. Subtract the given number from that 1 000 000 and 000, you will get the value as you can see here, 0 1 0 1 0 1 000. Okay, now by using steps, and the steps goes like this. Here drop 0 as it is. How many zeros from LSB? 3. So just drop 3 zeros as it is. Now a non-zero digit has occurred, and that non-zero digit in binary is 1, so keep it unchanged in the second step. And from now here onwards, just toggle all the bits, that is 1 to 0, 0 to 1, 1 to 0, 0 to 1, and goes on. See, by using the formula and also by using the steps, you got the two same results. And 0 here represents a positive sign. We'll talk about the signed and unsigned numbers in the upcoming videos. The second example here is like you have an integer part and you also have a fractional part, and in the integer part you don't have zeros. The first one is kept unchanged and then toggle. In the fractional part This is MSB and this is LSB. You got a 0 here, keep it unchanged. You got 1 right after 0, so keep it unchanged. And you are approaching towards now MSB, so just toggle all these values. Okay, now see what I did. 1 is dropped same as 1, and then I toggled all these values. And in the fractional part, 0 is dropped as 0, 1 is dropped as 1, 0 is kept same, and just toggle. You will get the result, this total value. Or you can use this 2's complement is equals to 1's complement plus 1. And 1's complement, you have to toggle all the digits irrespective of 0 or 0 is occurring from LSB or not. You don't have to see all that. You just have to toggle all the zeros and ones. And once you have done with the 1's complement, then just add a value 1 to the result, both in the LSB side of integer part and in the LSB side of fractional part. I added 1 into the integer part also, and also to the fractional part. Just remember this. Don't get confused that you have to add only 1 to the integer part. No, you have to add the 1 to the fractional part also. Octal, it is called as 8's complement, and it can be calculated with the formula or by just finding 7's complement and adding a unity value to that. And for hexadecimal, it is called as 16th complement. You can use the formula or just by finding 15's complement and by adding unity to that 15's complement. How you will find 7's complement? If an octal number is given to you and it is said to find the 7's complement of that number, what you have to do is just subtract that number from the overall 7's. This is 7's complement. And to find 8's complement, you just have to add 1, 325. And for 16th complement, do the same thing. Subtract from 15th and add 1. This is the hexadecimal number. It takes some value, random value like A, B, C, D. And just add 1. 3 you will get here. Uh, 2, 3, and again 15B is 4, again 5, 5, 4, 3, 2. Add 1. This is 5, 4, 3, 3. This is the 16th complement of that number. Okay, I hope you understand. If you have any doubt, please comment in the comment section. Thank you.